All right. Let me begin with a word of prayer. So here we go. Dear Heavenly Father, we thank you for this day. Again, I thank you for these students. Just ask you just guide our steps today. Help us to glorify you and what we do, and just understand a little bit more about your creation together, Lord. In your name I pray, Lord Jesus. Amen.
Amen.
All right. So I will begin by stating the factor theorem. So the factor theorem is an important tool that guides our thinking. And the factor theorem, all right, is for polynomials. All right, and I'm going to present it in two parts. All right, because we're interested in real polynomials, but the thing about real polynomials is sometimes they've got complex factors, right? So here's the deal. F of c equals to 0. That is going to happen only when I have x minus c as factor of f of x. All right? So this is what I would call the real factor theorem. All right? There's also a complex factor theorem. The complex factor theorem says the following. It says that f of alpha plus I beta equals to 0. What that means is that x minus alpha, quantity squared, plus beta squared is prime factor of f of x. So complex zeros correspond to prime factors of a polynomial. All right. Let me show you an example of this. So like example 1. All right. Give me a second here. I gotta conjure up something good here. So suppose we have f of x equals to x cubed plus x squared. All right. Minus 7x. All right. Minus 15. All right. And here's a fun fact. On the one hand, we have f of 3 is equal to 0. But also, another fun fact, f of minus 2 plus I is actually equal to 0. All right? Now, what does the factor theorem tell us if we're given these facts? All right? So, given these facts, what does this mean? F of 3 equals to 0. What's that mean? That means I can factor out a what?
X minus 3.
X minus 3 is correct, Mr. Cottrell. Let's see here. And then, so we've got something else over here. I'll leave that blank to fill in. Now, how about this one? F of x equals to what? This x minus 2 plus I. Let me tell you how to interpret that. So what we're looking at here is alpha equals to minus 2 and beta equals to 1. So if we have the factor theorem I've written right up here, all right, then we can use that to factor this. So if alpha is equal to minus 2, so I do what? X minus alpha 2 is actually x. What's minus alpha? See, if alpha is minus 2, x minus alpha 2 is actually x plus 2, right? So x plus 2 squared x plus 2 squared plus 1. So all I'm doing here at the moment is using my factor theorem. Now the factor theorem doesn't tell you how to factor it completely, right? It gives you partial information about your polynomial, right? Yes, Michael?
So for the fun fact equals negative 2 plus I. Where is the I in the? Oh, negative 2 plus I. The beta, I'm thinking, is x negative 2. So positive 2x plus 2 squared plus I.
Right.
Plus I.
So I'm
I beta.
right. I'm looking at the pattern. Let me.
1 beta.
So we look at the pattern here,
Plus 1 beta.
comparing that and that. You see that the alpha is minus 2. The coefficient of I, if you use your imagination, you see that's I times 1, right? So the beta is equal to 1. Okay? Now, let me multiply this out here. This is equal to x squared plus 4x plus 4 plus 1, which is plus 5. All right? So on the one hand, this fact that I'm magically given, all right, I just made it up, right? I mean, that's how I made this example, but I know f of minus 2 plus I is, when I plug it into here, it gives me 0. And when I plug 3 in, we get 0. Now, we could check the 3. Do you guys want to check the 3? If we plug in 3, why do we get 0? Should we, I mean, I can show you that one. But I don't, anyway, I'm not going to do that. So you guys help me out here. This is a factor. That is a factor. What has to go over here? Think through this. There's two things you can do easily. If you know x minus 3 is a factor of a cubic, right? It's still equal to all this, right? So the only way that can happen is if you have x squared here, right? And the only way I can get a minus 15 here is this minus 3 times the constant term here, which has to be 5. See, because minus 3 times 5 has to give me back the minus 15. Remember, factoring is just unmultiplying, right? So when I multiply out my factor, it has to go back where we started. So the x squared and the 5 are essentially for free. Now the middle term, that's tricky, right? But how about down here? If I have factored out x squared plus 4x plus 5, what do I have to put here? To get back x cubed, I have to put x, right? And, oh, this one's actually a lot easier. How do I get a 5 times something gets me back this minus 15? What do I have to put there? Negative 3, right? So, I mean, this is a kind of silly example because I've given you so much information. See, to tell you this much information is to factor it. This is like a sneaky way of factoring it, in some sense. Like telling you the zeros, this many zeros, essentially factors it. What goes in the middle? I haven't done this one. What has to go in the middle, obviously? Plus, yeah, plus 4x. Now, what? Plus 5, right? So, of course, we're going to come to the same factorization, whether we look at it from the perspective of the real factor or the complex factor, right? But by golly, if I give you a complex factor, man, that is a lot more useful, much more useful than like the real 0, right? Knowing that there's a quadratic, right, a prime quadratic, that's like a lot of information about how to factor the polynomial, right? Let me show you another one. Example 2. Excuse me. You're given f of x equals to, oh, let's say x to the fourth minus, oh, I don't know, 5x squared. Oh, let me think about this. Plus 6. I think that'll do it. Let me think about my life here for a second. I might want a minus 6. Let me think about it for a second. Yeah, minus 6. Yep, you have a question in the back? Oh, well, yeah, this was x minus 3, right? But I couldn't see it. My point is I couldn't see it there. It's not easy. It wasn't easy for me to see in the blue, because when I multiply that out like I did in the red over here, then I could kind of like piece it back together. But that would still be the x minus 3. It's just like, to be honest, I couldn't see it at that point. Does that make sense? So it's like it's a transitory part of the calculation. It wasn't done. All right, so let's do another one here. So let's work this one out. Now I just told you in the previous one that f of these things are 0, right? But this time I want you to, let's say, calculate f of 1 and f of I and factor appropriately over the reals. All right? So how do we calculate f of 1? What does that mean? F of 1 means that we put 1 in the place of x, right? So we plug 1 into x, we get 1 to the fourth minus 5 times, well, 5 times 1 minus 6, which is also known as what? That's not 51, that's 5 times 1, which is 5. Let me just leave it as 5. Yeah, sorry. Let me just leave that as 5. It's less likely to confuse. That looks like minus 10, right? Is minus 10 0? Well, it is not, right? So what does this mean? Whoever wrote this problem was just wasting your time, right? Like, that doesn't help us factor at all. What does it tell you? It tells you, if you were to graph it, the point 1 comma minus 10 is on the graph, but are we graphing it? No, so who cares, right? All right, so how about f of I? How do we do that? So that would be I to the power 4 minus 5i squared minus 6. Now let me tell you how I works. I squared is minus 1, right? By definition. So what's I squared times I squared? It's minus 1 times minus 1, which is just 1 again, right? So what does this mean? This, we're looking at 1, right? Minus 5, what's I squared? Minus 1, right? So what do we got here? We have 6 minus 6, which is 0. Aha! Well, that is helpful, right? Because that means we could use the complex factor theorem. Yep.
So when you put 1 into the f of x, you didn't do 5 squared. Why didn't you?
Well, I did 5 times 1 squared. It's just, 1 squared is...
Oh, it's
We just...
getting squared.
Right, yeah, we just plug it into the x, not everything. We have to multiply by 5, but we don't square the 5. Was that the other question as well? There were 2 questions. I'm not, yes?
For the 1 minus 5
Yeah. I mean, that's why I have minus 10 there, because minus 5 minus 6 is minus 11.
No, under it.
Oh, yes. Oh, man. What just happened? Rats. No! All right, this is going to be fixed. This is going to be fixed, folks. This is easy. This is easy to fix. Hold on. This is very easily fixed. I will fix it in red. Watch the marker carefully. Are you ready?
Yep, I'm paying attention. I've got this under control.
That's good. That's good.
Sorry if I got carried away.
No need to get carried away. We're going to put a plus right there, which means we're going to put a plus right here. Which, what? Wait a minute.
Oh no. I sense some recording editing coming soon.
Because if this is negative, it's also
Yeah, so then it would be 1 plus
If
5.
I had negative squares,
would be 6.
negative
6 minus 6 is 0. So what's wrong? Yeah, because the negative 6 is the one.
What's the problem? Yeah, you're right.
So then what?
There's nothing wrong with it. It's just not.
I square multiple, yeah.
There's nothing wrong with it. It's just not what I wanted.
It became too easy.
Is that much?
So what happened here? All right.
Correct all along.
So the tables have turned, and now we have what here? 1 minus 11, right? Which is minus 10. Rats. All right, so then what? Can you guys tell me another? I mean, this worked out so well. Is this function an even function? What was an even function, guys? Maybe you haven't learned that yet. Let me introduce this idea to you. An even function means f of minus x is equal to f of x. This is an even function. I think our formula is even. So what that means is whatever it does for plus 1, it will do the same thing for minus 1. So check this out. What is f of minus 1? 1 plus 5 minus 6. Guess what? It's still 0. All right? Rats. I really wanted that f of I to be 0. That would have been more fun. Oh well, my bad. So sorry. So there's still something to learn here. What do we have? We have 2 zeros for the function. What does that give us? What does this say? This tells me x minus 1 factor, right? This tells me what? X plus 1 factor. So what does that mean? That means that I can write f of x as equal to x plus 1 times x minus 1 times something. Now, of course, it might help to write it like this. F of x is equal to x to the 4th plus 5x squared minus 6 is equal to, let me go ahead and multiply these out, because if I multiply these out, it makes our life easier for the moment. That's x squared minus 1 times the thing in parentheses I haven't filled in yet. Can you guys help me fill in the parentheses?
Of course.
All right. What you got? I'll do the easy part. X squared. You're welcome, right? That has to go there because we have an x squared over here, right? Now I should leave myself more room. We could have 3 terms there, couldn't we? And how about this? How about this 6 over here? How can I get minus 6 from multiplying by 1? I have to do plus 6, right? Does that do it? Like, what happens when we multiply this out? We get minus x squared. We get plus 6x squared, so we get a plus 5x squared in the middle. We get our minus 1 times 6 is minus 6, right? That's it. So we've almost done. Like, factoring over r, what do we have to do to finish it? So to finish it, we simply do this. F of x is x plus 1 times x minus 1 times x squared plus 6. And there you have it. This polynomial now is completely factored over the reals. Remember, x squared plus 6 is a prime polynomial, right? We can't break that down further. Are we good? Do you guys, so I've been trying to show you guys the factor theorem because there's some problems in the homework and the mission, which is due Friday, by the way, that I have given you information about the zeros of the function, right? So you can use those to factor. That's the idea, all right? But that said, this kind of example, there's another way to solve it. Do you guys know? Let's look at example 3. What if I'm up against something like f of x equal x to the 4th plus 3x squared minus 2? How should I factor this? And this method we're going to use on this problem, we could have used on the last one too, right? We could have. How about this? If we look at it, this is x squared squared, right? Plus 3 times x squared minus 2. So if we make a substitution of y squared plus 3y minus 2, do you know what to do? See, it's actually, with this substitution, right? The substitution y equals to x squared, right? That's the substitution I'm making. This is a quadratic in y. So now we know how to factor, right? Like, even if it was ugly, we could still complete the square in y, right? We don't need that here, right? We can just factor this, right? I put a y here, I put a y here. I want a minus 2. How do I get it? Ooh. I think I made another poor life choice. Ouch. Oof. I guess we need to complete the square, don't we? Yeah. Sorry, I should have juxtaposed the 2 and the 3, but I'm not going to change it. I'm going to face the music. So what do? Complete the square, right? So we do y plus 3 halves, quantity squared, minus 9/4 minus 2, which is y plus 3 halves minus, let's see, how many? We got 9 minus 8, which is, I believe, minus 17/4. Okay, so then we can do our complete the square. So we got y plus 3 halves plus the square root of 17 over 2. And then y plus 3 halves minus the square root of 17 over 2. So by the way, what I'm doing here is 17 over 4 is the square root of that is equal to the square root of 17 over the square root of 4, which of course is the square root of 17 over 2. That's why I have square root of 17 over 2 there. Are we done? Well, not yet. Yeah.
I lost teacher.
So well, Michael's catching up. I have a question for you guys. square root of 17 over 2, how big is that? How does it relate to 3/2? Is this, my question for you, is this number right here, is it negative? Is it positive? What do you think? See, because this is x squared plus 1/2 of 3 plus the square root of 17 times x squared minus what? Well, plus what? Plus 1/2 of 3 minus the square root of 17. I'm pretty sure that 3 minus the square root of 17 is a negative number, because the square root of 17 is bigger than 4, because square root of 16 is 4. So what we're looking at here is a negative number. So to be fair, it would be better for me to write a minus here, like so, and just change the order to square root of 17 minus 3. Right? And then let me finish this atrocity of an example.
Hold on.
Don't worry, I'm not, Michael, I'm not erasing it, buddy. It's going to be here till the end of class. I'm not even going to erase it, okay?
Can I catch up after class?
Of course. In fact,
Sorry, I just get carried away.
well, this problem is like that. So,
But I'll try.
now, I think what a lot of your peers are going to do at this point is take a picture of this because they don't feel like writing it down, which is understandable. Yeah.
Was there, what was the point in jumping from the y equation to x squared again?
We're trying to factor the polynomial. See, Michael, look. See, they're all taking pictures.
Oh.
Yeah. So, what we were doing, remember the instructions are completely factor over the reals? So, the first, I switched to y so we know how to factor. Then I switched back to x. We're interested in the answer in terms of x, right? This right here is prime because it's x squared plus a number, right? But those over there, it's x squared minus a number. So, so there we do this, the completing the square. It's just super ugly because we get like roots of roots. Ugh. This, see, like I said, if I could go back in time and switch the 2 to a 3, everything would have been so much more pleasant. All right, so let us continue, guys. So I've shown you most of my tricks for factoring. I guess the other thing to talk about, I will talk about in the upcoming examples, but we need to shift gears here and talk about polynomial inequalities. All right, so how do you solve polynomial inequalities? The answer, the heart of it, is factoring. All right, it's all factoring. So let me show you an example. I'll try to start out with something relatively simple. You guys ready?
Great.
All right, example 4. So we're talking about polynomial inequalities. So here it is, example 4. Suppose we want to solve x squared. See if I can do it right this time. Minus 3x plus 2. Wait a minute, did I do it again? No, I didn't do it again. Haha. Less than 0. You want to solve this inequality. How do you do it? Here's how you do it. You factor this. X minus 1 times x minus 2 less than 0. All right? Step number 1, factor. Factor completely. Are we factored completely? We are. All right? Step number 2, identify critical numbers. Identify 1 and 2 are critical numbers. And by critical numbers, A critical number, let us agree, is a number which either makes the expression 0 or undefined. Now, there's no undefined for us now. After test 1, we'll extend this discussion to rational functions. Then we'll have division by 0, so we have that to look forward to. But at the moment, just places where it's 0. It's the only way this can be 0 by the factor theorem, right? Is if it...
1 and 2 are also known as the roots.
Right, yeah, at the roots. The roots are the critical numbers. That's what, exactly, that's what we're looking for. So then, we draw a number line, like so. And on the number line, we write down the critical numbers, and we write them in the order that they appear on the number line. All right? And then what you do is you simply plug in a number in each of the cases. So like we could plug in, excuse me.
Oh, it's okay.
0. 0's over here. If we plug in 0, what happens? Plug in 0 into the formula, I get what? Plug it up here is easiest. I get 2, right?
1
So,
minus 0 plus 2.
So minus 1 times minus 2 is 2, right? So plugging in 0 gives me 2. And so what I have is I have positive signs here. All right? Then, if you plug in, for example, like 1.5, if you plug in 1.5, what happens? 1.5 minus 1 is 0.5. 1.5 minus 2? Negative 0.5. So I've got a plus times a minus. What's plus times minus? It's minus. We don't actually care about the value. We just care about the sign. All right? And then if we plug in like 3, for example, what happens? We get 3 minus 1, 2, 3 minus 2, 1, plus times plus, we get plus. All right? Once you have this, you can write down the solution. Solution is...
Oh, they're the intervals.
Right, the solution is a interval. It is the 1 to 2. 1 to 2. That's it. These are actually very easy if you follow this method. Here's example 5. Same expression, this time x squared minus 3x plus 2 greater than or equal to 0. What's the solution? Look, I don't need to do more work. I already have this right here. This has the answer to my next example. Can you guys tell me what it is? When is x squared minus 3x plus 2 greater than or equal to 0? Let me make it red. Here, right? And here, right? That's the solution. And so what we have is minus infinity to 1 included, unioned with 2 to infinity. There you go. That's the solution to this problem. Do you notice I included the critical numbers in example 5? Why? Because we're solving greater than or equal to 0. Equals to 0 is something we're interested in. Here, we have excluded 1 and 2 because we're not solving equals to 0. We're solving strictly less than. So that was it. Yep.
Can you explain unions again?
Union just means you put it together. So to be in the union is to either be in here or in here.
Interval notation.
Right? Interval notation.
Okay. So it's like listing two separate parts that are both true for the answer.
Yep. So here's another one. Example 6. Suppose we were going to solve x squared plus 5 less than or equal to minus 4x. This is a kind of silly example. Can somebody tell me why? Well, maybe not. Let me not ask. So what should we do? the game we play here, move everything to one side. So we're going to trade this problem for the corresponding problem, x squared plus 4x plus 5 less than or equal to 0. All right? And then, what are we going to do? Well, you could try to factor it. What happens when you try to factor it? It goes nowhere. So instead we complete the square.
Complete the square.
That's right. So this is x plus
Sorry, I got carried away again.
x plus 2 squared. Don't get too carried away. X plus 2 squared.
I'm sorry. It's just how.
No, you're fine, Michael. So we complete the square, right? We take half of 4, which is 2. We add it to x. We square it. We subtract the 4. This is the completing the square.
So,
Which is what? Yeah?
parentheses, x plus 2 squared minus 1 is
Oh, how about this works out to what? Not minus 1 though. What?
1 plus 1
Plus 1, right?
is less than or greater than 0. So I believe this is not true.
Right. Yes, this is not true, right? Why is this not true? Michael's right.
That should be higher than 0.
Can you have, exactly, this is just like basic real number arithmetic. You've got something squared plus something else. Can that be negative? Can it be 0? What's the smallest it could be? 1, right? So what's the solution? So you either write like this, or sometimes the book will write like this. This is the empty set. If you like, you can just use words. No solution. That'll be fine. All right? Did I ever move the camera over here? I gotta get dead. Yeah. Yeah. Okay. Let us try something much, much uglier. You guys ready? Now this one, I'm not going to ask us to factor it. It's going to be factored for us. All right, you guys ready? Example 7. Suppose you're going to solve, well, it's almost factored for us. Well, I'll make a little bit of work for us. X squared minus 1 times x plus 1 times x squared minus 6x plus 9. And then we'll just throw in an x minus 7 for fun, greater than 0. Let's try to solve this thing. So while I'm adjusting my camera, I want you guys to factor that further if you can. Can we factor those terms? Is there anything that's common that we can, oh, thank you. Is there anything that we could like group together? Yeah? Thank you. You have to write it out and solve it. Yeah. I don't really have any multiple choice on my test. Although, I will say, it's tempting because I was grading something and my wife was like, complaining about the grading, and she's like, is it multiple choice? And I was like, well, no. And she's like, oh, I was going to grade it if it's multiple choice. And I was like, huh. So that's what's in it for me. If I could make it multiple choice, she has a master's in math. She's qualified. But anyway. But no, I don't usually give multiple choice. My tests, they're old tests online, right? Okay, so can you guys tell me how to factor this? This is what? We've got x plus 1, x minus 1 for the first term. You still got the x plus 1 there. This factors as x minus 3 times x minus 3. And then, of course, you got the x minus 7 greater than 0. Now, when you've got something like this, you need to collect like factors so you can see what's going on. All right? So what goes on here is we have x plus 1 squared times x minus 1 times x minus 3 squared times x minus 7. We're solving that greater than 0. All right, what are my critical numbers? we got a -1, we've got a 1, we've got a 3, we've got a 7. Now this is going to seem like a kind of silly comment, but it really matters. You must put the critical numbers in their order on the number line. Like this is the most insidious of all errors, is like putting your critical numbers out of order on the number line. It will corrupt the rest of your solution in ways you won't see. Yep. No? Oh, okay. There was a hand raised, wasn't there? Am I just imagining it? Okay, fine.
Yes.
All right, fine. I'll allow it. So maybe it was a waking dream. Let's see here. -1, 1, 3, 7. I am now going to share with you my trick. So my trick is this. Once you test 1 point, that's enough. See, in my other example back over here, I tested 0, 1.5, and 3. The truth of the matter is I didn't need to do that. If I just test 1 point, I can use the even-odd trick to propagate from there. Check this out. So if I try 0, if I plug in 0, that's easy. 0 is always easy, right? What happens with 0? You get what? So for 0, I'll write it out. I get 1 squared times -1 times -3 squared times -7. What is that? It's like 63. The value doesn't matter. The point is it's positive, right? Because you've got a net. Yep.
Would it not be -3?
I don't think so.
Minus, well, then the 1 would also have to be negative, so no, it would remain positive.
The -3 is squared, though. I mean, I've got a net 1, 2, 3, 4 minuses, if you want to think about it that way. Good question. But I'm pretty sure it's positive here. I mean, does anybody still disagree? I mean, all right, so here's, listen carefully. This is the trick. So I look at -1. All right? This corresponds, right? This -1 corresponds to this right up here, this term, right? That's an even power. The multiplicity of the factor is even. That means that the expression bounces there, which means it doesn't change sign. So I still got pluses over here. In contrast, the 1, there can be only 1, is this one. That appears just once. So there's a lot of 1s here. That's odd. If it was a cube or a 5 or a 7, you know, whatever, but if it's odd, it flips. So I go from plus to minus. All right? Now 3, what's the deal with 3? Right? What's the deal with 3? Well, 3, if I can find another color, 3, that's this one, right? The multiplicity there is 2, which means it bounces. And when we look at the bounces, means the sign stays the same, so I stay negative. All right? And then at 7, what am I up against? Just x minus 7, right? So as you go across that, you're going to flip signs again. You got pluses here again. Now, if you don't like my sign flipping theorem, you could pick a number in each subinterval and test it. Let's double check, right? Let's double check. What happens if we try putting in like 8? What would happen if we put 8 into the formula? I get 9 squared times 7 times 5 squared times 1 plus, 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 all pluses, right? So it's positive. Woohoo, it checks. So you could check the other cases as well. Do you see why that's easier? I don't actually have to think about numbers. I just have to look for the multiplicity of the factors. If I find one sign, I can propagate from there. That's the smart way to do this. Now, so now I can solve the problem. Where is it positive? What's the solution? So we've got what? Minus infinity all the way to minus 1, not included, right? And then union, Yowzers. Minus 1 to 1, union with what? 7 not included to infinity, right? If I had included equality, I could have dropped the union over here and just written it as like minus infinity to 1, for example. Any questions? If you understand these 3 examples, you should be able to do all of these kinds of problems. To summarize, the method is this. Take the polynomial inequality you have, rewrite it as a polynomial either less than or greater than 0, factor that polynomial, and use the number line method. That's all there is to them. Yep.
My question would be, could you explain the multiplicity of the signs of bouncing numbers one more time?
If it's even, it stays the same sign. If it's odd, it flips signs.
So that's between the terms.
Yeah, going from one case to the next.
Okay.
Yeah.
Oh, that makes sense now.
Mm-hmm. This, see back here, these were both odd, so it changed signs both times.
Oh.
Wait, what makes something odd?
Multiplicity is like the 2 squared.
Another way to look at it is the even terms are irrelevant because they never change sign. Like the, whatever squared